flash.
Hi, Elena. Everybody says hi.
Flash the top bit so she can copy it down.
Yeah, in case she.
Elena, we also added in the interval of convergence and all that kind of stuff on the previous question.
You can ignore the brackets because you need it in the X minus C format.
That's just gonna confuse her.
No, it's not. No, it's not. Maybe she had the same question I did.
Okay.
Guys.
All right. So anyway, you guys are gonna love this one. It's fair. Yeah. Yeah. You guys, are you with me? That rewriting the natural log of x is unpleasant in the form that we want to write it in.
Is there another way to
Take the derivative.
Oh, you mean the...
So what we're going to do is take the derivative of the natural log of x. What is the derivative of the... Okay.
Is there a competition on this? I wasn't informed.
Oh, I have. Girl. So sorry. I'm so depressed.
You got 45 minutes less of sleep.
Plus C.
Yeah.
No, it's
Are you guys with me that we know how to write 1 over x as a power series? In fact, we did it like 2 seconds ago. Like at the bottom of the previous page, yes? So that means we can say that f prime of x is equal to negative, I'm sorry, I forgot the series.
This is new. See, we're like cooking.
Yeah.
I don't know what's going on.
Is that what we should memorize?
Nah.
Okay. Because we literally the same code we did here.
Yeah. I know. Thanks.
Everybody good?
Yep, sure.
Okay, now, I was not trying to approximate the derivative as a power series. I was trying to approximate the natural log of x. So, I need to integrate both of these. Oh, by the way, that we said that this one converges on 0 to 2, yeah? That's probably worth noting. Okay, so if I integrate f prime of x, what do I get?
F.
All right, what is the integral of this? Couldn't tell you.
And we assume it's
This
1
is
over
something-
x.
U sub.
U sub.
Oh, wait, no, it's one of those.
Is it one? Is it? Do we have one that's like?
Is it not 1 over x?
There was a rule, wasn't there?
No, it is not 1 over x. What are you doing with your ends?
You guys, when we do this, the ends are like constants, yes?
Yes.
Because we're integrating with respect to x, yes? Okay, so
So maybe we just like...
I'm still adding all the terms together. That negative 1 to the n would just be in front of our x, yeah? And then how do we integrate something to the nth power?
That to the n times natural log
Pull
of
it
n.
down.
Oh.
Wait, I said up one.
Why are you dividing it?
Oh, yeah. What
Because
is
it's
that? Why was I
integral.
tripping?
So if I ask you to integrate x to the third, it becomes x to the fourth, 1/4 x to the fourth, yeah? You divide by, it's the same thing. You guys, there's no way you're making this mistake. There's something missing here.
Plus C.
Plus c.
I said it earlier when we derived.
I know, but I don't even want to, I can't even, yeah.
Okay.
Something's like in the air.
Just
Senioritis.
Girl.
Guys, you can have senioritis in 1 week,
I know.
okay? 1 week.
We're still with you.
You guys can't. All right.
Elena, you can't either.
Elena, you're not allowed to have senioritis in a week either because you're not a senior yet. Okay.
A weekend a day. That's giving you more space.
I'm listening.
Stop.
You guys, we have a slight issue here, yes?
Yes.
What is it?
The C.
The C, right? We need to figure out what the constant is. Everybody with me?
Yep.
What are we plugging in?
No, you
I
should
think we
say
gotta
If you
solve.
look at anything, like just set the ln x equal to all
Yeah, that's
that,
what I
and
was
then
gonna say.
evaluate, and then you can decide.
So here's how I would do it. What do we know f of 1?
Yeah.
Like that's like the easiest point on a natural log function, right?
Zero.
Is at when x is equal to 1, y is equal to 0. So that means this whole function should equal 0 when x is equal to 1. Is everybody with me? Okay, so we got 0 equals the sum as n equals 0 to infinity of negative 1 to the n times 1 minus 1 to the n plus 1 all over n plus 1, which is all 0. So my f of x function is the summation with no c.
Will we ever do it where n like starts at 1?
Not using when we're using this geometric, because the geometric series n starts at 0. Okay. Where does this converge?
1.
All.
Okay,
That's
it's
okay.
centered at 1.
Isn't it all? It's because you have the 0 on the top.
You don't always have the 0 on the top, right?
Yeah. Is it not?
Is it O to 2 then? Is this inner
It-
thing?
Okay, so Friday, was it Friday or
We didn't have class on Friday?
we didn't have class on Friday?
It was
Thursday we talked about that for derivatives and integrals, they have the same interval, but you have to check the endpoints,
But it's also the same, right? Because it's less.
right?
Wait, no, it's different now.
So derivatives and integrals of power series will have the same interval, but you may or may not include the endpoints.
So we have to check that.
So we have to check the endpoints. So if I plug in 0 for x, so if I look at this, you guys,
The top is always.
the top is always -1. Because when this term is even or is positive, this one would be negative.
So both of them are going to be the same.
They're always going to be opposite signs,
Which makes
And then
it
negative times.
which makes it just -1 on the top. So we have 1 over n plus 1. Are we converge or diverge? That diverges. Okay. And then when we check 2, this converges because it's an alternating series.
Wait, why did we say
So this simplifies to 1 over n plus 1 if we did limit comparison with 1 over n.
n goes equal to 1? Or is like just like a p series? Or?
1 over infinity is always
Well, yeah, 1 over, yeah, but that's just the limit. That's just showing that the limit of the series is equal to 0.
Yeah, that's just what we're doing,
No.
Sure.
That's nth term test.
The nth term test can only tell us if something diverges. It doesn't tell us if it converges. However, 1 over n diverges. Yes? P series, P is equal to 1,
Yeah.
which is not greater than 1. Okay? So,
But that's a greater function. Because I thought if it, the comparison. Oh, because you're doing line.
if I did, which is why I would do limit. So you would take the limit as n approaches infinity of 1 over n plus 1 times 1 over n. And if that has a value, these two series would do the same thing. So because 1 over n diverges, this... Everybody good? So that's my interval of convergence. We would include the 2 for that one.
So if it converges, we include it, if it diverges, we don't.
Correct. Because we're giving the interval of where it converges. We good?